Unveiling the power of MQTT, revolutionizing IoT communication. Imagine you're a device and you want to share your data, like temperature readings, with other devices. Instead of sending this data directly to other devices, you send it to a post office, called a broker in MQTT. This is known as publishing. Other devices that are interested in your data tell the post office that they want to receive any data you send. This is known as subscribing. The post office, broker, then makes sure that any data you send, publish, is delivered to all devices that have expressed an interest, subscribed. This way, devices can share data without needing to know anything about each other. They just need to know about the post office, broker. This makes it a very efficient way for devices to communicate, especially in situations where network resources are limited. MQTT is a lightweight messaging protocol for small sensors and mobile devices, optimized for high latency or unreliable networks. It's a publish, subscribe, extremely simple and lightweight messaging protocol, designed for constrained devices and low bandwidth, high latency or unreliable networks. MQTT as a futuristic post office for IoT devices. Key features of MQTT. Publish, subscribe. This is like a radio station, the broker, where devices can tune in, subscribe, to the topics they're interested in, or broadcast, publish, their own messages. The broker ensures that all messages reach the devices that are tuned into the specific topic. Lightweight. MQTT is designed to be very simple and use minimal network resources. It's like sending a postcard instead of a large package, which makes it great for devices with limited processing power and network bandwidth. Quality of service. COS. This is like choosing the delivery service for a package. You can choose from 3 levels. COS 0. Standard delivery, where the message is sent, but there's no guarantee it will be delivered, like regular mail. COS 1. Confirmed delivery, where the message is definitely delivered, but there might be duplicates, like leaving a voicemail. COS 2. Exclusive delivery, where the message is definitely delivered and there are no duplicates, like registered mail. 4. Retained messages. This is like a sticky note left on the broker for any new devices that subscribe to a topic. They receive the last message that was sent, so they're immediately up to date. 5. Last will and testament. This is like a device's final message before it disconnects. It's a way for a device to let others know that it's going offline, which can be useful for monitoring and managing devices. MQTT is used in many IoT, Internet of Things, applications where a small code footprint is required and/or network bandwidth is at a premium. Use cases. Real-time analytics. MQTT can be used to stream data from devices to servers for real-time analytics. The server can subscribe to topics and process the data as it arrives. Remote sensor networks. MQTT is ideal for remote sensor networks due to its low bandwidth usage and ability to maintain connections over unreliable networks. Sensors can publish data to specific topics, and any interested parties can subscribe to these topics to receive the data. Home automation. MQTT is often used in home automation systems. For example, a smart thermostat could publish temperature data to a topic, and the heating system could subscribe to this topic and adjust the heating based on the data received. Vehicle telematics. MQTT can be used to send data from vehicles to a central server for tracking and analysis. This could include data on vehicle location, speed, fuel usage, etc. Healthcare. MQTT can be used in healthcare applications to monitor patient data in real time. For example, a heart rate monitor could publish data to a topic, and a healthcare provider could subscribe to this topic to monitor the patient's heart rate. Industrial automation. In industrial settings, MQTT can be used to monitor and control machines. Machines can publish data on their status, and control systems can subscribe to these topics and send commands back to the machines. Mobile applications. MQTT is also used in mobile applications to provide real-time updates and notifications. The lightweight nature of MQTT makes it ideal for mobile applications where bandwidth and battery life are often limited. Best practices for using MQTT in IoT applications. Use the right quality of service, COS. MQTT supports 3 levels of COS. Choose the right level for your application. COS 0 is the lightest on network traffic but does not guarantee delivery. COS 1 guarantees delivery but may result in duplicate messages. COS 2 guarantees delivery and ensures that messages are not duplicated, but it requires the most network traffic. Secure your connections. Use Transport Layer Security, TLS, to encrypt your MQTT connections and protect your data from being intercepted. Also, use strong authentication mechanisms to ensure that only authorized devices can connect to your MQTT broker. Use retained messages for important data. If there is data that new subscribers need to know immediately, like the current state of a device, use retained messages. A retained message is stored on the MQTT broker and is sent to any client that subscribes to that topic. Plan your topic structure carefully. Topics in MQTT are hierarchical and case-sensitive. Plan your topic structure in a way that makes it easy to subscribe to a relevant set of data. Keep your payload small. MQTT is designed for low-bandwidth environments, so try to keep your payloads as small as possible. This is especially important in IoT applications where devices may have limited processing power and memory. Implement proper error handling. Ensure your MQTT client can handle network interruptions and MQTT broker unavailability. This could involve implementing a reconnection strategy or buffering messages to send later. Use last will and testament for detecting device disconnects. MQTT's last will and testament feature can be used to notify other devices if a device disconnects unexpectedly. This can be useful in IoT applications to detect when a device goes offline. Limit the number of connections. Each connection to the MQTT broker consumes resources. If you have a large number of devices, consider using a gateway that aggregates connections from multiple devices into a single connection to the broker. Challenges in implementing MQTT. Network connectivity. IoT devices often operate on unreliable networks. If the network connection is lost, the MQTT client may need to buffer messages to send later, which can consume memory and power. Security. Ensuring secure communication is a major challenge. Without proper security measures, sensitive data can be intercepted. It's crucial to use encrypted connections, like TLS, SSL, and strong authentication mechanisms. Resource constraints. IoT devices often have limited processing power and memory. MQTT is lightweight, but the application still needs to be carefully designed to manage resources efficiently. Scalability. As the number of IoT devices increases, managing a large number of connections and messages can be challenging. Quality of service, COS. Choosing the right COS level can be tricky. Higher levels provide more reliable delivery but use more network resources. The right level depends on the specific requirements of the application. Power consumption. For battery-powered devices, keeping power consumption low is essential. Even though MQTT is efficient, the device still needs to manage its connections and messages to conserve power.